Welcome guys, yet to this another series on Python for machine learning. Now in this tutorial we will be learning about Scipy, which is a very important library for mathematical computation and numerical computing. So basically we will be discussing on what exactly is Scipy, and we will be comparing it with Numpy. And finally we will be discussing on the sub packages which are included in the Scipy library, and then we will be doing some mathematics which will include some basic functions, special functions like integration and all. And finally we will be ending up this session by doing some of the that is the linear algebra. Now going on with what exactly is Scipy. All right, so there you go. What is exactly Python Scipy? So it's actually an open source library which is used to obviously solve some scientific and mathematical problems. Now it is basically built on Numpy, so you can call it as an extension of Numpy. Now it is a really open source, since Python is open source, so even this library comes free. Now this contains some of the modules for greater mathematical purposes like optimization, linear algebra, integration, interpolation functions, and also it can be used for signal and image processing. Now we actually use ordinary differential equation to solve these kind of problems in scientific and engineering domain. Now let's compare it with Numpy, and what exactly is the difference between Scipy and Numpy. So Numpy actually contains array data and basic operations, whereas this Scipy consists of all the numerical codes in it. So Scipy, we can call it as a fully featured version of mathematical and scientific computation. So we can call Scipy as a more advanced version of Numpy. Now these are some of the sub packages in Scipy which we will learn while we do some coding in it. Finally we will learn all these things, these basic functions, how does it work in the notebook itself. So let me turn out into our notebook. Alright, so here I am onto my notebook. So firstly I will start with the basic functions in Scipy. So let me just write this. We will be starting off with the basic functions in Numpy. So it's basically how do we do some help, how do we find information about anything. So let me just zoom it. So in order to find or information about something, you need to import anything. Like for example, if you need to know about cluster, so you import cluster from Scipy, you import cluster, and then you just write help cluster. Now once you do this, you will get all the information required for clustering. So there you go. Clustering algorithms are useful in information theory, target detection, communications, compression, and other areas. So it's basically used for vector optimization and quantization in the k-means algorithm. So you can get information like this. You just type from Scipy and import anything you want to, and then in help you can include that particular parameter. So that is what the basic functions means, where you get information about any sort of things in it. Now we go with some of the special functions in the Scipy. Now special functions, by I mean this as the functions which are available for mathematical physics. Now these include some of the functions like gamma, beta, hypergeometric, parabolic, and cylindrical equations as such. Now basically I have divided this into two parts, which is the exponential functions and the trigonometric functions. So once you see here, you will get two types of that, which is the exponential and the trigonometric functions as a part of special functions. So let me just begin with the exponential functions. So let me just write this. We will start learning on with exponential functions. There you go. Now what we do is, from Scipy you need to import this library or this function called as special, which is for computing, for mathematical computing. Now let's suppose any variable as a, and let's say we have to find exponential of 10 power 2. So you need to type is like special dot exp exponential of 10, which is square of it. You write it like this, and you just print a. Now you get 10 square, which is 100, right? Now we move on to trigonometric functions. How do we deal with trigonometric functions in Scipy library? So let me just type in the trigonometric functions. Now in trigonometric functions, let's write a code to calculate any angle, let's say sine 90 degree, right? So from Scipy you need to import again this function called as special. Now let's say a is a variable which consists of sine 90 degree. So you need to write it as sine dg and then 90, which will give you a value of sine 90. Or let's also keep another variable and name it as special dot. Let's again calculate the value of cos degree 90 or let's say 30. Anything we can calculate it. And let's just print a and print b. Let's see what it gives. Alright, so there you go. Sine 90 degrees obviously 1 and cos 30 degree comes somewhere around 0.86. So that is how you do trigonometric functions in SciPy using the SciPy. Now we do the integration function. You calculate it like this. We calculate this thing, which is the integration of x square, where the limits are 0 and 4. Now the basic formula for this is anything x power n dx is xn plus 1 upon n plus 1. So let's learn it. How do we do this using SciPy in Python? Now what I mean by integration function is, now integration deals with adding slices to determine the whole, right? Now it can be used to find either displacement, area, and etc. So there is a variable in SciPy which is quad. Quad calculates the integral of a function which has one variable, and double quad, which is db quad, or sorry, dbl quad, which calculates the double integration of a function which has two variables. So since we have only one variable here, we will be doing quad variable. So let's learn how to do this. We will be calculating this thing. Now it's really simple. From SciPy we import a special function called as integrate, which will integrate our values or any sort of problems we have been given. Now we define a variable called x2, and then we define a lambda function, which is an anonymous function in Python where we can keep any sort of mathematical values there. So our problem is x square, right? So we will write it as like this, x times square. Now we integrate here using the quad variable, which I told previously, and we will write it like this. And the limits of our integration are 0 and 4, so we will keep the limits as 0 and 4. Now we calculate this. So there you see, it has successfully calculated our definite integral, right? So in indefinite integral we get a constant value c, but in definite integral we get an exact value. So it has calculated the exact value from the integrate function, which is a special function to do integration. And quad is actually which calculates the integral of a function which has like one variable, right? Now we learn about the linear algebra. So let's do some linear algebra here. Now in linear algebra we will be learning on how do we calculate inverse of a matrix. So this we have done already in our high school mathematics. So we will be doing in Python how do we actually calculate the inverse of a matrix here. So let me write just finding the inverse of a matrix. So let me write a code here. Now in order to find the inverse of a matrix, you need to import this library called linalg, which is linear algebra. Import linalg. Now we define a variable a, which will contain some array. So it will, for array we need to use the numpy y. So you write it like this, and we define an array, a two-dimensional array like this, 1 comma 2, and let's keep another as very simple terms like 3 and 4. So once you do this, you have created an array like this. And now what we do is b variable, which will store the inverse of this thing. So we will write it as linalg dot inverse of a, which is calculate the matrix of a. So since two-dimensional array is a matrix, so b is a variable which will store the inverse of matrix a. Now we will just print b. So once you do that, you should get the value of this. All right, so name np is not even all right, so we need to also import the numpy y. We need to import numpy y as np. So now once we do this, yeah, there you go. You have successfully calculated the inverse of a matrix, which is -2, and this one is 1 point something. And yeah, that is the values you get when you do the inverse of the matrix. So that is it for this tutorial. Thank you for watching.